So our next keynote speaker is the Director of Blockchain and IoT Platforms for IBM Research. In his role, he oversees IBM Labs' R&D efforts in blockchain, IoT, cloud, wearable solutions, and emerging cloud computing platforms. He has an MSc and BSc in electrical engineering from the Technion and an MBA from the University of Haifa. While IBM is a household name and its services and technology are well known, its involvement in blockchain for finance is much below the radar, and that's exactly what he will be addressing here. So it gives me great pleasure to introduce Gabi Zodik, please.
And thanks for everyone. Pleasure to be here. And thank you. In the next 30 minutes, I'll be covering not the entire strategy we have around blockchain, but a few topics, in particular tokens and asset-based tokens. And earlier today, we talked a little bit about cryptocurrency and the differences between that. And I think after my talk, it will be much, much more clearer. I'll start just to say a few words about the blockchain technology. I know not everyone here is technologist, so I won't get too deep. But because I think one of the promises that maybe is less emphasized around blockchain is the fact that it is a decentralized technology. I mean, it has many other qualities, and we all know that blockchains brings the ability to have this ledger and to run transaction, and everything that's written into that ledger keeps and is permanent there, and we have all these consensus algorithms that make sure that the transactions are correct, and we can create transparency. But I think when we think about businesses and why it is so relevant to so many industries, the fact that it comes and it allows us to run things in a decentralized way is one more of those characteristics that I think it's less emphasized, at least. And why do I emphasize this capability so much? Because oftentimes when entities, organizations are collaborating among each other, one of the things that they need to build up in their relationships is really trust. And one of the things that decentralization brings to the table is the fact that we can run this computing environment, these transactional systems with its ledger and everything, in a decentralized way. That means that there is no single entity that acts as the center, that acts as the single point of failure or the single point of authority or whatever you'd like to think about this. But everything that these organizations who decide to collaborate and have a business network among themselves is run in a decentralized way equally among all of the partners. Each and every one can propose transactions. Each and every one can participate in approving those transactions. Again, it depends on the role they are having in the network and how they define the policies. But this is one of the major or additional powers that blockchain brings to the table, and that's why it's so relevant to many, many businesses. I'm sure by now that you've heard multiple talks about blockchain, and if you think about what really business is about in many of the industries, it's really exchanging values, it's exchanging assets, it's having marketplaces, it's being able to sign contracts and do transaction among one or multiple parties. And blockchain brings a lot of those capabilities. As you'll see later on, we have the ability to write those things that we call smart contracts that really define when and how those transactions are executed and how and when those transactions are valid. And then there is a policy or a forum in which you define when such a transaction is approved. In addition to that, blockchain brings also capabilities for auditability in a very, I would say, simple, relatively, and very organized way, with the fact that we have this common ledger in which everything that we do is written down, and once the consensus algorithm decides that it is a valid transaction, it is kept there, and for any practical reason, we can read it and prove that certain things happened for certain reasons, and that's the auditability capabilities. Finally, when parties come together, as I said, trust is one of the main issues. They want to be able, from one end, to share some information in order to make some joint business. At the same time, they want to keep privacy. So I'll get back to that with some more examples when I talk a little bit about the research challenges. But being able, at the same time, to keep what is private to me private, and share what needs to be shared is also part of the basic capabilities that are, I would say, easier implemented with the blockchain technology. Now, I'll go over a couple of examples from IBM that just illustrate and emphasize the capabilities that blockchain brings, one of which you may have heard or may have read is TradeLane. This is a joint venture we've done with Maersk, the largest shipping company in the world. And by now, most of the large shipping companies joined this network. And more companies are joining. And you can think about this as a logistic network in which we are tracking shipment of containers worldwide. The benefits, I would say the most basic benefits that you get immediately is just the ability to track the container. I can give you from my personal experience, I once ordered a car I bought it from the US, I bought it to Israel, and at one point in time I called the shipping company asking where is my car. They had no clue. They said it might be in one of the ports in Israel, it might have been back in Turkey for some reason because there was some strike, but we really don't know exactly where it is. So that's just an example of a simple question that I had something unknown for a couple of days or actually a week until they figured out where my car was. So just the basic capabilities is needed, and that's things that this network provides. Of course, this network is expanding as we speak to include everything that happens in the ports themselves and eventually what happens in the land. So when you send you as an end user, you can track it entirely through the entire life cycle. I think the other benefits that we immediately gain is the fact that we digitize everything. I mean, this industry is heavily done by manual processes, paper-based processes. Once they started using blockchain, all of these are literally going away slowly. Another part that's connected to this, and it's growing, is banks and insurance companies, because at the end of the day, whenever we are buying goods, we need oftentimes to get some loans, so we need to have some guarantees for the things that we bought or we plan to ship in. And the banks need to be part of this network as well. So you see how these things are coming together to build, in some cases, one network, in some cases, as you see, a network of networks. One other example, really quick, is the one that, again, we started with Walmart. By now, we have many, many other retailers. It's Food Trust. I don't know if you know, but almost 1 in 10 people every other day has some food poisoning because something was wrong, the food was spoiled in the way it arrived. Oftentimes, for the manufacturers, they have no, for some other reason, they may have manufactured something wrongly. They need to do a recall. Usually, they have no clue where the products are, so they just have to recall everything from all of the stores worldwide. And with Food Trust, one of the things we do is the basic provenance, meaning that we can track each and every item, whether it came from a certain farm somewhere in South America, and now you as the consumer get the product in the supermarket, you can track down and know exactly from where this vegetable arrived or where this product was manufactured. And the value for the manufacturing is that it knows exactly for each and every product on which shelf, in which store it is located. If it needs to do a callback from a certain factory, it doesn't have to do a callback across the globe. It can focus on those particular items that were really damaged. If we take it a step further, one of the things we are working here in research is to introduce more AI and analytical capabilities into these networks. So for instance, with TradeLane, one of the things we can do is anticipate, for instance, if a shipment is about to miss a deadline for one reason or another, and it might miss the time it needs to get to its next hop in the shipment. It might have to do multiple hops with multiple ships. So we can alert the shipping company so that they can take some action either to prevent it if it's possible, and in those cases when the unfortunate case that it missed the ship and it will be arriving later, maybe they need to notify the end users about the fact that their shipment is arriving late. In the Food Trust, I'll give another example. One of the things is freshness of the food. So think about vegetables, milk products, and meat products, and these kind of things. When they are shipped, they need to be kept in certain temperatures and certain conditions. And if you deviate from those conditions, the freshness of those products is reduced. Think about some vegetables that were kept in higher temperature than what was planned. Even if you get them, instead of having a shelf lifetime of a week, it may be reduced maybe for only 3 days. And if it was kept too much in the sun, it might be completely spoiled by the time it gets. So all of these things can be tracked and propagated through the network, while from one end, as I said, preserving the privacy of the manufacturers, of the suppliers, and the retailers. I'll move on more touching to this topic of the conference, I guess, which is blockchain creates opportunities to create new markets or new exchanges, okay? And we've seen the rise, I guess, of cryptocurrencies quite like a decade ago or more. But what the kind of marketplaces that we see that are emerging now, that the customers, our customers from IBM, is more asset-based. And I'll get to a few examples. And you'll see, okay, I mentioned already the rise of tokens. I can skip this. But the kind of businesses that we see growing is this, where tokens have really are representing a digital form of some asset. Could be a physical asset, it could be gold, could be metals, could be something that's more virtual, like IP rights, okay? Could be digital rights on digital media. In a sense, tokens, as I was saying earlier this morning, is the digital representation of some, oftentimes it's a physical asset or a virtual asset. It's kind of a new term that we use here in the, I guess, blockchain community, financial markets, and so on. But there is equivalence to this term in other industries. So those who came from the IoT industry, as an example, we use a term that we call digital twin, which means for many physical assets, we have a digital twin that represents that physical asset. Think about a manufacturing site. They have a lot of machinery around them, air conditioning and machinery and whatever. Each and every pieces of that equipment has a digital twin. Usually we have back-end systems that allow us to manage their life cycle, to repair them, to do predictive maintenance, so on and so forth. Tokens are, in a sense, similar in concept to that. They are the digital representation of these assets, and they allow us usually to represent the value those assets have, and they allow us to change ownership, do exchanges, sell them, so on and so forth. So there is a lot of equivalence in between these two words, and I believe there is also a linkage between these words in the sense that we could trade and link those physical assets oftentimes with tokens. So I've mentioned the kind of things that we could do. One of the benefits, I would say, of introducing these concepts of tokens is that it increases the liquidity, or it increases the ability to trade on things that in the past were either very hard to trade, they were not usually in stock exchanges, or it opens it up to many more customers that in the past didn't have the access because the amounts or the initial investment was way too big. In this case, you can take a bar of metal, let's say gold, and allow people to buy pieces of it and trade it. And you have the digital representation, and you could do that. So again, this is just examples of those things that could be represented by tokens. I don't think I've mentioned here, but it could be all the way to patents and digital rights and almost, the more we work in this space, we realize across multiple industries that there is almost endless number of things that could be represented with tokens. And the more we do that, well, one of the things that I didn't mention here is the fact that we need more standardization in this space so that we can actually exchange those tokens or be able to connect and preserve the semantics between the networks and pass on the values. And I believe we'll get there. It's just an issue of maturity of where the market is. So a very simple example of one of the customers we worked in research, the Bullionist, is the example of, in this case, it's gold bars. So there is, the first step there is the issuer who maybe has might be the mining company. They would mine and create these bars of gold. Custodian is really a place where you need a place to keep them, because oftentimes when you're trading with these gold metals, you don't really take them home. And then there is, the primary market, and again, represented by tokens, you can fractalize it and sell pieces and allow people to buy a piece of that larger bar of gold. And in this case, Will is buying, he's the end user, represented by tokens, and the system will create some digital token for him to represent his investment, so on and so forth. He can further trade those and sell the rights for that to his friend Bob, and eventually Bob, might sell that gold. Those tokens will be minted in that case, and, he would get back his money. If I move on, just to show some other examples, we see where, again, tokens play a major role, more in the finance industry, I guess, is the simple act of transferring payments. How much and using blockchain, we've seen how much it could be automated, simplified, and reduced cost, and also taking out, oftentimes, third-party. Oftentimes it's the central bank, sometimes it's some other third party that has to approve many of those transactions, oftentimes makes the transaction and everything much slower and certainly much more costly. And with the use of blockchain, with all of the qualities that I just mentioned, all of these things could be automated. There is no single point of failure or no centralized entity that manages those. And we can certainly automate also all of the settlements that need to happen between the parties. And it might take a few rounds, but we automatically can do that. And this is true for domestic payments, and it's true also for cross-border. It is important to mention that in the case of cross-border, it's, again, and as it was mentioned this morning, these industries are emerging, and there is need for more regulation to capture what is allowed and how it is allowed to be done. And I think that's still a gap, because the technology in this case enables to do much more than where the regulation exists. And you would see that more and more organizations that are not originally banks or financial institutions, in this case could be IBM, who can provide such services, need to be able to do so under certain regulation, but not regulations as if we were a bank, because again, IBM is not a bank, and we have no intentions to be one, okay? But we do want to provide services like this. I already mentioned one of the challenges or examples, and I'll cover a few of the research challenges now just to give you a flavor, and I won't get too deep, but it will give you a sense of areas we are investing and spending our time. We phrase it in general, network of networks. So oftentimes we have, or we are building, and it's still emerging, as you see, a network that specializes to trade a certain kind of asset. So it might be, think about a network in which I want to sell my car, and there is a trade of cars there. There might be a different network in which we are actually transferring and doing the payment itself, as I was saying earlier. Now, these networks can run independently, but oftentimes there needs to be some linkage between these two networks. I'll give an example. For instance, if I sold a car to you, and I want to get some money for that, these two transactions become dependent on each other, and they act as an atomic transaction, meaning that only if I actually passed on the rights to the car to you and I received the money, both of those transactions should be written into the ledgers, into the different networks. So that's one of the challenges that we need to overcome when we're running distributed systems like this across multiple networks. In another case, it might be the case that I want to ask the other network about certain value it has. For instance, I want to ask who owns that car. Now, oftentimes we think, okay, that's pretty simple. I can just go to one of the nodes, write a simple application, and just ask it. It can go and read from the ledger and tell me the answer. Well, if you want to be more precise and more safe and secure, that's not really a good enough solution. Because under these networks, although these typically are permission-based networks, meaning that you know who are the participants in the network, you validate it and so on, still it might be the case that the node that you are accessing and asking the question, it might be a malicious one, okay? It might act Byzantine. It might give you the wrong answer. So you need more guarantees than asking a single node. In fact, you need something that's more similar, like the approval or the same thing that happened when you actually wrote a transaction. So you need some, and there are mechanisms. We are building a relay mechanism in which when we are asking a question, the neighborhood network, we don't get the answer just from a single node, but really from a subset of those nodes to get much more guarantees and proof that that's the correct value that's actually there. I mentioned the privacy. There are multiple issues or challenges around that, and there are multiple techniques around that. I really don't have the time to cover all of them. Maybe I'll give you just a few of the examples that we are looking at. One of the techniques that is being used is called zero-knowledge proof, in which what we mean by that is that I don't actually disclose the information because I want to keep it private, but I can provide you some proof so that you know that I actually have the right data. I'll give you some examples of, for instance, my son goes to a bar, and he needs to prove that he is at least 18 years old. Usually what he has to do in these days is take out his license driving or his ID, and he gives to the barman. Of course, the barman can see everything about him that's written there, not only his age, but really his address and so on and so forth. And that's way too much information that we are disclosing. So think about a way in which we can provide some proof that he is actually 18 years old or more without actually disclosing the rest of the details and not exactly the age, because it's irrelevant if he's 21, 22, or 25, as long as he's bigger than 18. That's the techniques that you need to use in zero-knowledge proof. I'll give you another example. Think about trade lanes. So trade lanes, the partners would like to know among themselves how they are performing compared to the others. Let's say arrival time, okay? So I, as a shipping company, want to know if I'm better than my competitors, worse, medium, more or less like the others. Of course, no one of the shipping company is willing to share that information. Nobody would like to say, you know, if they are by average late, I don't know, an hour or a day with their packages. So how can we do that? Well, in a network like blockchain, we can share that information anonymously because I don't really care who the information came from. We can actually compute the average in this case very easily, and then I can compare myself to the average without actually knowing from where those information came, but I do have the guarantees, and that's what blockchain provides me, that the data is actually correct and valid and the true data. You've seen here the slide, and I don't get too much into the technicalities of Hyperledger Fabric. That's our open source project in IBM that we are contributing, and we are building our product around it. Of course, any technology company here is more than welcome to join that or build on top of it. And many of those capabilities that I've mentioned are available in the platform. Tokens is something that, as I was discussing with one of my colleagues, we had a beta capability that would allow you to build these kind of token-based solutions. We've taken out what's there, and pretty soon we'll come up with a new capability to allow you to really build these kind of solutions that are token-based, whether they represent physical asset or digital assets, and so on and so forth. And it will provide all of the basic functionality, meaning that if you want to introduce the capability to transfer values between one personal warranty to the other, it would track how much affordability each of them has and make sure that nobody can overspend and nobody can cheat by doing multiple transactions at the same time and overspend the amount of money they have, while again preserving the privacy of each and every party, but still giving enough information, for instance, to auditors to see the transactions and everything that took place. So that's a basic capability. So privacy, I already mentioned. I think I gave you a couple of examples. I just spoke to the different slide. Let me take you to a little bit a different world now, which is the world of supply chain and how blockchain relates to supply chain and IoT. And I've mentioned, for instance, that the trade lane is sort of a supply chain logistic network, or food trust for that matter, in which we track the products coming from manufacturers or farmers to the stores. One of the challenges many industries have, for instance, pharma industry, is to make sure that the actual product, the original product that was manufactured actually arrived to the store or eventually to the patient. Now, with blockchain, if you go and document the entire process that drug went through from manufacturing through the supplier, through the retailers, through maybe the doctor and so on, you can track that it actually made the correct pass, but there is no way to actually prove that it is the original one. In Africa, for instance, millions of people die every year because counterfeit because drugs are replaced with fake drugs, or in other cases they are stolen. But the more severe case is the fake drugs. And crypto anchors is really the technology which allows you to attach a cryptographically unbreakable. You can think of that as a more sophisticated RFID tag, which not just has an ID, but it's cryptographically encrypted, and nobody can decrypt it, of course, and only when it arrives to the final user, he can validate that it is actually the original product that was manufactured by the fact that he has the public key, he can decrypt it and check against, for instance, the manufacturer that indeed it is one of the original products. Now, crypto anchors have many forms because it depends what is the product that you want to attach it to. It could be an expensive, I don't know, bag. It could be a drug, which is a small that maybe costs a few dollars. So it varies. So do the crypto anchor technologies would vary. But this is the way in which we would enable that through the supply chain, we can actually validate the originality of the product. Another example of another technology we are developing is called Verifier. In this case, we use, and it is a mobile application that's developed. It reads the return wavelengths of, let's say, liquids or various other materials, could be diamonds. And what it would denote if it is the original or not original material. Think about olive oil. Oftentimes it is diluted with water. So in this case, with the Verifier, you can know that it was diluted or was not diluted. You don't know that this is actually, like with crypto anchor, the certain part number that came from the manufacturer, but usually you don't really care as long as you know that it is the original oil and it was not tampered with anything. And again, it could be working with diamonds, with many kinds of materials. So this is a family, and again, I just gave you a couple of these crypto anchors, but think about the future of logistics or supply chain in which you can have not only all the information about how the product went through, how much time it spent, at what temperature, in what conditions, so on and so forth, but also if it is the original or not. I don't really have more time. I think I'm running out of time. I think we've seen and we see more evolutions. I think you've seen with, for instance, Facebook with Libra. I think there are many other interesting attempts in which we see that money is changing forms in the way that we can create, as I said, new markets and new ways in which we manage those. And again, the infrastructure, the blockchain capability that I've mentioned are enabling to do those things in a very, I would say, safe way, in a way that is very cheap to do, so that you can eventually, I didn't mention, but when you're doing cross-border payments, oftentimes if you do them today, they cost tens of dollars just to transfer a small amount. When you do it with technologies like blockchain, the amount or how you have to pay is dramatically smaller by several order of magnitudes. Finally, I think I'm not the first one in the conference, many already said. I think we certainly, technology companies such as IBM understand blockchain technology. We can bring that, and we can develop a lot of great solutions across multiple of these markets. I think we certainly have some understanding of financial models, and some of these models will change because the technology enables to do some new things that were not possible in the past and could streamline some of those processes. But as I've mentioned, and prior to me, and I'm sure after me, we need more regulation that's adapted to these kind of technologies and these kind of solutions. We cannot just take the existing regulation that exists in place, certainly when we are building these new kind of solutions that are not something that we had in the past. That's it. It was pretty quick. There is a lot going on in IBM, and as I said, I just mentioned a brief of that. I'll still be around here and be happy to take questions now or later.
We have time for one question. Anyone?
Sure.
I don't know if this is too specific, but I'm curious in what areas this technology might apply to fraud. So, for example, telephone fraud, where people are misrepresenting companies, and maybe some layer of verification of, are you speaking to the people who are actually, from the firm that you're, and so maybe it's too specific, and
No, it's certainly applicable in those cases. We are actually encountering something similar to that. So in that case, you will need to have to find the equivalent to the crypto anchor that would validate that the person who is speaking is actually the person speaking. And we have, in voice recognition, capabilities to do user authentication and user validation. So we could use those techniques to actually validate that someone is. But again, I always challenge, and it deserves a longer discussion, whether we need blockchain there for the particular scenario that you mentioned. If it is only authentication of end devices or users, so on, we don't really need blockchain just for authentication. If it is really a transactional system you're building, distributed with all of these qualities, then probably yes. Yeah.
We're going one more. Could I ask, on Hyperledger Fabric, what is the biggest use case, or by either number of transactions or number of users or size so far?
I don't remember them by heart. I think these examples that I gave, Food Trust, TradeLens, are pretty big networks now. I know that in TradeLens, about more than 60% of the C logistic is already running on trade lanes. So that's a pretty big number. I don't know if it's the biggest one, though.
Okay, thank you.
Sure. I think I'm out of time, so I don't know. One more, and I'll be around, and I'll be happy to chat more.
Sure. Thank you. Just a quick question, slightly related to the first question, whereby you're talking about quite specific commercial applications of the blockchain, and I think the utility there is often traceability. But where there's more trust issues involved or legal compliance issues involved, has there been a focus on solving the problem of dealing with or preventing fraudulent entries on the blockchain as a concerted plan to defraud based on that blockchain evidence later on?
So I didn't get into that, again, just because lack of time. There is a lot of work around that. I'll maybe mention just a few, just to give you a sense. So the consensus algorithms that I've mentioned, in which we, even in a permission-based network, we are agreeing on the order of the transaction and the validity of the transaction. That's a pretty sensitive thing. And if one of the nodes is malfunctioning intentionally or not intentionally, it could be malicious, it can change the order of transaction or the correctness of those. And you may be attacked by multiple nodes, not just a single one. So that's why we're developing consensus algorithms, not only we, also the others, that are Byzantine fault tolerant, meaning that even under attacks, and you could assume that up to a third of the nodes could be attacked and act maliciously, still the transactions will be written correctly. So just one example. And there are multiple other things we are doing to prevent or also work correctly under attacks. I'll give you maybe one more example. Some of you hear and read the news about quantum. As you know, we have a quantum computer in IBM. We already released quite a few, tens of number of bits. It can do various computation. Oftentimes, people ask, when do I need to move to be quantum safe? Blockchain is one of those examples, because oftentimes, things that you write in the ledger now will last there for tens of years, because that's your document of the transaction that happened today. And even if quantum computers will be relevant only in a decade from now or 2 decades from now, you still want to be quantum safe. So we are working to make, for instance, Hyperledger Fabric quantum safe even now, so that anything you write now will be safe even in 2 decades from now. So there is more work around that. But all right, thank you guys, and I'll be here.